Synchronous up-down counter. A counter which can count in both directions, upward as well as downward, that is in the increasing order as well as in the decreasing order. So I will talk about 3-bit up-down synchronous counter. You can design 2-bit, 4-bit, 5-bit, 6-bit, n-bit up-down counter in the same manner. But I'm going to take an example of a 3-bit up-down synchronous counter. So first of all, what is up-down counter? A counter which can count in both directions, increasing or decreasing orders. That is why it is also known as bidirectional counter. So with the help of 3-bit up-down counter, we can count in increasing order, that is 0, 1, 2, 3, 4, 5, 6, 7, or in the decreasing order 7, 6, 5, 4, 3, 2, 1. With the help of these up-down counters, we can count and we can change the sequence in between as well. For example, you can see it over here, example 0, 1, 2, 3, 4, 5, 6. This is in the upward direction, and then we have created it as a down counter 5, 4, 3, 2, then again up counter, then again down counter. So we can change the upward direction or the downward direction in between the sequence as well. So this is the truth table of up down counter. These arrows are defining the directions for the upward or the downward. First of all, the upward direction. Upward direction means it will count 0, then 1, then 2, then 3, 4, 5, 6, 7. After 7, it will count 0. Recycle condition. On the other hand, what about the down counter? In down counter, first of all, every time we have to start with the initial condition 0, 0, 0. After 0, 0, 0, it will count 7, 6, 5, 4, 3, 2, 1 and then 0. So what about the connections? In this circuit diagram, we are just going to combine upward as well as the downward counters that we have already discussed in the previous videos. So this is the key, up/down bar. Up is active high, down bar is active low. So when up/down bar is equal to 1, the circuit start behaving as an up counter, whereas when up/down bar is equal to 0, the circuit start behaving as a down counter. We just need to combine upward as well as downward counters together. So first of all, up/down bar directly given as such in the upward directions over here, whereas it will be given through the NOT gate to the downward directions. Why NOT gate? Because if its value is 0, then it will behave as a down counter, but actually we require a signal 1 for the implementation through AND gate. So 0 will be converted into 1. So first of all, in the upward direction, we require Q0, Q1, and for the downward direction, we require Q0 bar and Q1 bar, as we have already discussed. Now class, first about the connections of flip-flop number 0. So every time flip-flop number 0 is going to be connected, that is J0, K0 is going to be connected with a high signal. As you can see it over here, either it is upward or downward, it is going to change its value every time. So Q0 is always going to toggle 0, 1, 0, 1, 0, 1, 0, 1, either upward direction or downward direction. So that is why flip-flop number 0 is directly connected with a high signal. Now what about J1, K1? First of all, for the upward connection, Q0 dot up, that is for the up connection, Q0 bar dot down for the downward direction, and both the signals has been given to OR gate. So that means when this signal is equal to 1, that is we require up counter. So 1 dot Q0 will be Q0. On the other hand, 1 through NOT gate 0. So 0 multiplied by anything is 0. So we will get the upward directions through Q0, Q1. On the other hand, when up slash down bar is equal to 0, so the upward wire will become equal to 0. So 0 multiplied by anything is 0. So Q0 and Q1 will not be used, rather 0 through NOT gate will be 1. Now in this case, Q0 bar and Q1 bar will be activated and our counter will start behaving as a down counter. So this is the working of up counter slash down counter, or we can say it as a bidirectional counter. So this is the operation that I have already discussed. J0 K0 is equal to 1. J1 K1 is equal to Q0 dot up signal plus, that is OR gate, Q0 bar dot down. So this is for up counter and this is for down counter. And the last is J2 K2. Q0 dot Q1 dot up plus Q0 bar dot Q1 bar dot down. You can see it over here. So this signal is already Q0 dot up dot Q1, and this below signal is already Q0 bar dot down dot Q1 bar. So these are the connections and the values of our up down counter in the synchronous mode. That is the same clock signal to all the flip-flops.